Hi, I'm James Ward, a developer advocate at Google. The session is on comparing Docker methods with Scala, and so we're going to go through some different ways to Dockerize applications. And so if you want to get to the source code for this, it's all on my GitHub, github.com, James Ward, comparing Docker methods dash Scala. Okay, so let's dive right in to this project. So I've got a Scala project here, a really basic one. And of course we can run this thing. So if we come in and just do our SBT run, we can see it's just going to be a little web application that's going to just respond with hello world. So let's go check this thing out once it compiles here in our browser. There we go, up and running. Let's go to localhost 8080. We see our hello world. Great, so we can see that this thing works. Let's go see what the code is. It's not very interesting and is just about as basic as we can get with no dependencies. I'm using Scala 3, so there's some fancy syntax here. But you'll see I've just got an HTTP server, an HTTP handler that says hello world, and wire all that stuff up. So that's my basic application. To containerize this thing, we need to first be able to package it up into everything that's needed to run this on the JVM. And so to do this initially, what I'm doing is I'm using the SBT native packager plugin. And then if we look over in my build.sbt, I've told it to enable the plugin Java Server App Packaging. So what this enables us to do is go and run SBT and then stage. When we run SBT stage, what this is going to do is take our application and the dependencies, package those all up, create some start scripts, and we can see those in the target universal stage directory. So that we got a bin and a lib. If we look in our lib, there's not really many dependencies in this case, just the Scala library and my application. And then we've got the start script to start it. So we can actually run that thing to see how it works. Let's go to here and then let's start it up and we'll see. Sure enough, it starts just the same way that it did before. Okay, so we are able to package up our application, but now let's package it into a Docker container. And so the easiest way to do this is we're going to use what's called Buildpacks. And I've got the pack tool installed, and I've got Docker installed locally. And now what we can do is run pack build. We do need to tell it which build packs we want to use. I'm going to use the Heroku build packs because those have support for SBT. And then I'm going to tell it the Docker container name that I want to package it into. So now you'll see that the Heroku build packs are running on this project. It is detected, hey, this is an SBT project, and I know how to build an SBT project. So it's going to install the JDK, run SBT, compile stage, and so that's going to do the packaging just like we saw before. So now this is actually running inside of a Docker container itself, and so that provides a nice reproducible way for us to package our application up. Okay, there was some cache stuff that it pulled from, so it didn't have to do a full rebuild and all that. So it ran faster the second time around, which you didn't see the first time around, but it would download the dependencies and cache those and that sort of thing. Okay, so now that we've got our Docker container package up, let's make sure that this thing can run with Docker. So I'm going to do my Docker run. I'm going to set the port environment variable, map the port 8080, and run that thing. And you'll see it's listening on port 8080. So if we connect to it, it's running just like it did before. Okay, so let's go look and see what's inside of this container. To do so, I'm going to use a tool called dive, and I'm going to go inspect that, that build pack created container image. And then we'll be able to look and see what all is inside of this container image. So here we go. Here we see an overview of my container image. You'll see that my total size of my container image is pretty large, 691 megabytes, and we can see what's actually in each layer. Layering in Docker containers is nice because that provides us with a great way to do caching. So if I've already downloaded a particular layer, then I don't need to do it again, and that means I can invalidate higher up layers of my application and it won't have to reload lower layers, that sort of thing. So if we look through and see this base layer, 63 megs, this looks like it's the base operating system. And then it adds in some more pieces into this. We get to this large 466 meg layer, which is the operating system, some other stuff in there. And then if we continue walking up, we can see that it adds, the Heroku Buildpacks adds some other things in. Then we get to this 159 meg layer, and in here we can see it adds in our workspace, and our workspace has in it our application, has the target directory, has the JDK that was installed. So that's a pretty large layer here. So we can see all the stuff that we saw in there. Okay, and then there's a few other layers for some build pack needed stuff. So this particular Buildpacks created container image is fairly large. You can use other build packs that do a bit better job at creating more optimized layering in the container image. But let's move on to the next method, which will see better layering for our container image and more optimized. So what I'm going to do is check out the Gib branch. Gib is an open source tool that is sponsored by Google, and it is able to create container images and has plugins for Maven and Gradle are the main supported ones, but then there's a community one for SBT. Okay, so let's go take a look at our plugins in SBT. You'll see that we're using the SBT Gib plugin. And one of the nice things about Gib is that if you run it locally and want to install a container image into your local Docker daemon, you can do that. But if you're doing a remote Docker daemon, you don't actually have to have Docker running locally. So that's a nice feature of Gib. Now let's go see how it's configured. So I've got some configuration settings in here to tell it about the registry, the organization, name, version, and then the base image that we want to use. And then I have a way to override that with a environment variable so that I can easily switch out the default settings for where it stores that container image. Okay, and then same source code as before. Let's go take a look at our instructions. We're just going to run this SBT Gib Docker build, and so let's go do that. So now this will use that Gib tool to take our application and turn it into a container. So it's running Gib on this project, and we'll assemble those layers, assemble our container, and then again we'll use dive to go check and see what's actually in it. So that worked pretty fast. There's good incremental support in Gib. So now let's use our dive tool, and let's go inspect our container image, which is our Scala web app, and then the tag here is Gib. Okay, so now you'll see this image is a lot nicer in terms of size, 138 megs. We see some base layers here, which are the base operating system and the JVM. And we can walk through those layers and see what's going on. But let's go look now at the 7.2 megabyte layer. And so this is a layer just for our dependencies in our application. So you'll see that, that we've got the dependencies here on our Scala library, and so that's nice to have a layer with just our dependencies, because then if we don't change our dependencies, then we don't have to invalidate that the cache of that particular layer. Okay, then if we go to the next layer, then we'll see here's my compiled classes for my application. So so it's nice to have those separated out, creates a lot more concise and better cache friendly container image. So that's Gib, and again, if you want to use it not against a Docker container image, then you can, or not against a local Docker daemon, then you can run a different task, which is Gib and then image build, and then we would need to set that image URL in my case to tell it the coordinates for where to store that, but you wouldn't need a local Docker daemon. So that's a nice thing about using Gib. Okay, so that is a great option for containerizing your Scala applications. Now let's go on to the next one. So let's check out another branch here, which is going to be the Docker branch. And now in this example, what I'm using is back to the SBT native packager, but in this case, I'm actually going to use Docker as the way to containerize this application. You may be familiar with the kind of traditional way of containerizing applications, which is you'll do like Docker build and tell it to build the stuff in dot, and then you have to have a Docker file that then Docker reads as the instructions for how to assemble the container. And so SBT native packager has kind of a nice way to do that type of containerization. So let's go take a look at our build SBT. So we need to have a way to package up our application like before. So in this case, I'm using a launcher jar plugin, and then I'm also have the Docker plugin from SBT native packager. And then I have to set some settings for how to package this thing up and how to start it. And then, like before, we're telling it how to override the default coordinates for where to store this container image if we want to store it on our remote container registry. So let's go run this one, and the way that we do that is we run sbt docker publish local for publishing to our local Docker daemon. So like before, this is going to take our application and turn it into a Docker container, and it's going to do that through packaging up the application using the, if we look back in our build.sbt, using the launcher jar plugin. We could have also used the one that we used in the beginning, but this one, I like this one a little bit better for how it packages up the application. So we can go look and see how this thing actually built the image. And let's go look in the target directory and then Docker and then stage, and you'll see that there's a Docker file here, and then there's two layers that it has added here. So this is the different layers. You'll see the op docker, bin, lib stuff. So we get our lib that has our launcher jar and our dependencies, and then if we look into stage 2, then we see our actual application. So we can see where the SBT native packager stored those. But we can also now go look at the Docker file that was created. So I'm going to actually pull that up here in VS Code. And if we look at our target directory, then Docker stage. So we can see that what the SBT native packager plugin actually did was really just to package the application and then create a Docker file that then it runs Docker build against to containerize the application. So that's how it worked in that case. And now let's go use dive again to go check out this this container. So this is the Scala web app, and then the Docker tag on there. And so almost, I think, just about the same exact size as the Jib one, because we're using the same base image in this case. And you can see that in my settings build.sbt. You'll see that I'm using the distro list Java distribution there. So the same base images. And then if we look here at our 7.3 megabyte layer, you'll see that it's organized a bit differently than Jib organized it, but essentially the same. We've got our dependencies in a given layer, and then we've got our compiled application. One difference is that it compiled our application into a jar file, whereas Jib left it as class files. I don't know if either of those is particularly better, but at least we have the nice layering in this case. Okay, so that is our SBT native packager option for using Docker underneath the covers to build this. And there's a lot of flexibility with this particular method and can result in nice, concise images like you just saw. Okay, so I do want to show you one of the nice things with container images before we get on to GraalVM, the last example, is that once we have things in container images, we can run those things really anywhere. And so I'm going to go to one of these methods. Let's go to the Jib one here. And I'm on the Jib branch in that repo. And I just want to show you how we can take this container image and put it onto a container registry. To do this, I'm going to use this Run on Google Cloud button here, and this will walk through a couple steps. So yes, I trust my repo, and then it's going to launch me into Cloud Shell. And in Cloud Shell, it's going to do some steps for me to get this application built and then up and running. Yes, and I want to authorize it to do all that stuff. Okay, so it's cloning that repo. I need to tell it the project that I want to use. And then yes, US Central. So it's doing the SBT Docker build, doing the compile, doing the build of the container image, and then it will take that container take what it built, turn it into a container image. Okay, so that's going to take a minute to run because it needs to do a bunch of stuff. While that's running, let me go show you where it's going to store these container images. And we could also, of course, do this all locally. But if we go over to the container registry, this is where it's going to actually store that container image. So if we search for comparing Docker method Scala, we'll see that I've built some images. Here's the Jib one that I built recently. But once we get the container image built and onto a container registry, then of course we can run this thing wherever you can run containers. So you can run it on Kubernetes, you can run it on just any host with Docker, GCE if you're on Google Cloud, and you can run this thing on Cloud Run, which is serverless for containers. Okay, so this is finished building the container image. It's done the Docker push of that container image to the container registry. And then, of course, we can deploy it wherever it can run containers. So I'm using gcloud run deploy, deploying that container image. And now that it's up and running, we can go check that container image out on the cloud, and it's going to start up that application. And great, we're up and running on the cloud. Cool. So you can run those container images really anywhere. And so if you go to that repo and go to those and click that Run on Google Cloud button, then that's an easy way to kick the tires and see how that works. Okay, but now let's move on to our last example, where what we're going to do is use GraalVM to create a optimized version of our application, ahead of time compiled version of our application, and we're going to do some nice tricks to with that as well. Let's check out the GraalVM branch, and if we go take a look at what's in here. What we'll see, first let's look at our plugins SBT. I'm still using the SBT native packager to package the application. And then I'm using this GraalVM native image plugin. And this allows me to use GraalVM native image to take my application and compile it down to a native image. I did have to go down to Scala 2.13 because I'm waiting on a dependency that hasn't yet been released for Scala 3. And then we specify some options for GraalVM. So first, I want to create a static image. Static image is statically compiled, and then there's a way that we can include all of the system dependencies that are needed through a library called usul in here as well. And then there is a thing in native image where you can tell it to fall back to running in JVM if it can't create the native image. And I don't want to do that. And GraalVM also has a way to use a server. I'm going to install some exit handlers. Okay, so those are my GraalVM native image options. So let's go open up our Docker file so we can see what's going on. But what I want to show you first is that we can't just use SBT and run the thing to create the native image directly, and this will actually run native image, GraalVM native image within a Docker container to create that. So that's great that we can create the native image for our application, but what I want to do is I want to create that native image, but then I want to package that native image up into a container image as well. And so there's a few things that I need to do. And so I've added a Docker file to this repo for this example so that I can do some other things on top of just creating that native image. So the first thing is that I need to be able to build my native image. And so I'm starting with a container image, which is my GraalVM community edition there. And I'm telling it that this is my builder image. So what this means is that what happens in these set of steps in my Docker file are actually going to get thrown out of my final container image. So I copy my program in, I install native image, And then I need to do some stuff to do my static compilation with Musel. So there's some stuff here which I just got from GitHub as an example there for how to compile what's needed for native image to do the statically linked image. Okay, so then I create my native image, and then what I'm going to do is I'm going to say from scratch. So start with a container image that has nothing in it and copy what was compiled, that natively compiled executable, copy that in as /webapp. And then set the entry point. So that's what's going to be, it sets what's going to be in my final container image. So let's go and run that now. And let's get the command here for my Docker build. Okay, run that Docker build. We're going to set the tag on my container image to Scala web app GraalVM. And so now it's running all this stuff within Docker. And so this is going to take a minute to go through and do all the compilation that's needed for native image to do the static linking, all that kind of stuff. Okay, and then it's going to create the container image, which is the longer part of all that. So the nice thing about doing the ahead of time compilation on this project is that it will be able to create a executable that doesn't have any of the unused stuff in it, doesn't have the JVM, so it doesn't have the overhead of starting up the JVM and of all the other parts, memory constraint, memory usage stuff that the JVM uses and that kind of thing. This is especially useful for auto-scaling environments where you want to be able to scale down and scale up quickly. And when we're using GraalVM, it allows us to get much faster startup times and also much smaller container images, which we'll see in a minute. So now is the long part of this build where it's got to actually compile the application and then take the compiled application and turn it into that container image, native image, and then container image. Okay, so that's going to take a minute to run. So we'll talk a little bit more about GraalVM and some of the nice things here as we get those benefits for startup performance, but there are some challenges and some trade-offs to doing that. One is that GraalVM needs to know about reflection, or you need to not use reflection. Luckily in Scala, we don't do a lot of reflection, and so typically, and so it can be sometimes easier to deal with that constraint in GraalVM. But there's also some other challenging pieces to GraalVM because it's doing all this ahead of time compilation. Things like method handles sometimes can be challenging. And so that's actually why in this particular project, why I had to go down to Scala 2.13 is that to work around one of the issues with method handles, I had to include this Scala meta SVM subs to enable GraalVM to work around that, and that wasn't released yet for Scala 3. So there are some challenges to being able to do GraalVM native image stuff, but there's cases where it certainly can be worth it. Okay, my application is now compiled, and it's compiled into a jar file. And so one of the nice things about GraalVM is that when I'm doing local development, I'm using the JVM. I'm running the JVM. I've got some hot read load cycle that is making my developer productivity nice and nice tight loop for testing my changes. But then in my production CI/CD system is where I actually do my GraalVM build into that, taking the jar application, the jar, and turn it into that native executable. And so because that takes a while to do this part of turning it into the native image, it's not something that I want to have as part of my typical developer cycle. It's something that I leave just for CI/CD. But I'm showing it to you here so we can actually see how this all works and get it all up and running. Okay, so now it's actually doing the GraalVM ahead of time compilation, and that takes a while. See, that took a minute to do on that very small, simple application, but great. It was able to turn that application into a native image, and then it added that into a container image. So now let's do our dive into this container image so you can see what's running up in there. And Let's check it out. Okay, so now you'll see that my whole container image is only 12 megabytes. I didn't have to have a base operating system. Everything that was needed is included in this 12 megabyte container image. So no JVM, no operating system, and then we statically compiled that Musel library with the parts, the native bindings that were needed there. And so nice small container image. Okay, just to validate that this is all working, let's run this thing just so you can see. Sure enough, it works. So we run that thing, should start up super fast because we don't have any layers, we don't have any JVM to start, and so yeah, so that's our GraalVM, and of course, you can run this container image, that nice small container image, anywhere that container images run. So on Kubernetes, on Cloud Run, or wherever you want to run your containers. Okay, so those are our 4 methods that I wanted to walk through for comparing Docker methods in Scala. There's Buildpacks, Gib, the kind of traditional Docker method with some made a little bit nicer by the SBT native packager plugin, and then GraalVM, which uses both a Dockerfile and SBT native packager. So in terms of what you should use, I like Buildpacks when I want something just to be easy, don't want to have to think about it. Buildpacks work on lots of different types of projects. So you can run Buildpacks on Maven projects, on Gradle projects, on Ruby projects, Node, Go, whatever, and Buildpacks will do it. There's also a really great Buildpack ecosystem out there that has lots of different Buildpacks. There's the Paketo Buildpacks, there's the Google Cloud Buildpacks. So it's really great when you don't want to think about how your application gets turned into a container image. If you want to do a little bit of work, then you can use Gib, which is nice, creates nice, concise container images. And then you could use the SBT native packager plugin, which had pretty similar results in packaging as Gib did. But underneath the covers, what that was using was Docker. And so if you are in an environment where you don't want to use Docker, then you can use Gib and store your container images on a remote registry, where if you're okay running on Docker, then that SBT native packager option using Docker is great. And then GraalVM, of course, great if you're doing serverless stuff or have other needs for starting up really quickly. So yeah, those are the 4 options that I wanted to walk through. So hopefully that was useful, and check out the source code and the different examples there, and let me know what you think. Thanks.